Guys, welcome back to our channel. So today we are starting another chapter of MHT-CET formula marathon. So today we begin with superposition. Till now we have completed 11th max and 12th max as well, and 11th physics as well. 12th physics we are continuously doing. After this there is more content coming up for solving bases and for elaboration also. So till that time, please subscribe our channel, hit the bell icon and do comment. So today let us begin with superposition. So now, first formula of superposition is omega is equal to 2 pi n divided by, so it is not. Let's begin with first formula, which is omega is equal to 2 pi n is equal to 2 pi by t, 2 pi by t, k is equal to 2 pi by lambda, v is equal to n into lambda. This is a formulas which will be really helpful. Now, general equation of particles. What is the general equation? It is y is equal to y x comma t function of x comma t a sine kx minus omega t. A is amplitude, k is over here is k is equal to 2 pi by lambda, which is wave number, lambda is the wavelength, omega is the angular frequency, v is equal to omega by k, which is speed. So here one more we have y is a function of x comma t is equal to a sine kx plus omega t. So here this is along negative x direction and this is along positive x direction. Now propagation along positive x-axis, a y is equal to a sine omega t minus kx. After substituting omega and k values, what all we can get more, that I have put up here. Y is equal to a sine 2 by t by t x by lambda, a sine 2 by n t minus x by lambda, a sine 2 by n t minus x by v, a sine 2 pi by lambda v t nu t minus x. Similarly, propagation along the x-axis over here, the changes will be positive only. None, most of the changes is positive. Now let us go to resultant of the wave equation. So resultant of a wave equation, y is equal to y1 plus y2, which is a1 sin omega t plus a2 sin omega t plus 5, which is equals to a sin omega t plus 5. Resultant amplitude a is equals to root of a1 square plus 2 times of a1 a2 cos phi into e2 square. So case 1 phi 1 resultant amplitude is maximum. So a maximum is equals to a1 plus a2, because there is 1, so you can get this answer. If amplitude of the waves are equal, that is a1 is equals to a2, so a max is equals to 2 times of a. Now let us know about the case 2. The resultant amplitude is minimum. So here we can get is a is equals to root of a1 square plus 2 times of a1 a2 into cos pi plus a2 the whole square, which is equivalent to root of a1 minus a2 the whole square. So here a minimum is equals to mod of a1 minus a2. If amplitudes of wave are equal, so a1 is equals to a2 is equals to a, then resultant amplitude a minimum is equivalent to 0. Now the intensities of wave are proportional to square of their amplitudes. When phi is equals to 0, I max proportional to a max whole square. So a max is a1 plus a2 square. When pi is equals to pi, I minimum proportional to a minimum the whole square. So it is proportional to a1 minus a2 the whole square. Therefore, intensity is maximum when two waves interference is in phase. It is in phase maximum there when it is in phase, while intensity is minimum, two waves is out of phase. This is also important. Equation of a stationary wave on a stretched string. So y is equals to y1 plus y2. So both equations we have. So final, after putting each an equation, everything. So we have y is equals to a sine 2 pi n. So this is the formula method. So I need to give you the final crisp formula which will be useful. So in this detailed explanation of how did we get this everything I have with me. So more lectures will be coming, the detailed sessions will be there. In that detail how we get this formula and everything will be there. So now here we have more options. So or y is equals to a sine omega t. So omega over is equals to 2 pi n. So we get this. Now condition for node over here, nodes points of minimum displacement equals to 0. So 2a cos 2 pi by x divided by lambda equals to 0, or 2 pi x divided by lambda is equals to 0. So cos, so over here 2 pi x by lambda, this is nothing. So now this is 2 pi x by lambda is 1 pi by 2, 3 pi by 2, 5 by 2, so on, and x is equals to lambda by 4, 3 lambda by 4, 5 lambda by 4. So x is equals to 2p minus 1 lambda by 4. P is 1, 2, 3. The distance between two successive nodes is lambda by 2. Now let us know about the condition for antinodes. So condition antinodes are points of maximum displacement. A is equals to plus minus 2a. So 2a cos 2 pi by x lambda is equals to plus minus 2a, or 2 pi x by lambda is equals to plus 1. So by solving each and everything, so we get here 2 pi x divided by lambda is equals to 0, pi, 2 pi and 3 pi and so on. So x will be 0, lambda by 2, lambda, 3 lambda by 2 and so on. So x is equals to lambda p by 2, where p is equivalent to 0, 1, 2 and 3 and so on. So similarly successive successive antinode is lambda by 2. Therefore, distance between a node and an adjacent antinode is lambda by 4. This is also important. End correction is equal to 0.3 into d, where E is end correction, d is inner diameter of a pipe. For a pipe closed at one end, L is equals to L plus C. For a pipe open at both, L is equals to L plus 2. Now pipes closed at one end only odd harmonics 3 and 5 and 7 present as overtones. Fundamental mode will be lambda is equals to 4 into L. N is equals to V divided by 4L. N is equals to V divided by 4L plus E. Pth overtone over 2p plus 1 harmonic. So lambda p is 2L divided by 2p plus 1. So Np is equals to 2p plus 1 into L. So by getting this, n is equals to VL by 4. 2p plus 1 into V divided by 4L. Pth overtone. And correction applied to state 1. E is equals to N1 and N1 L1 minus N2 L2 divided by N1 N2, or E is equals to N2 L1 minus N1 L1 divided by N1 minus N2. Vibrations produced in a string. Frequency of vibration of string. N is equals to V by lambda equals to 1 by 2L into T by M. V is equals to T by M. The lowest frequency or fundamental frequency of vibration or first harmonic. Here to overturn P plus 1 harmonic, Np is equals to P plus 1 into N. Np is P plus 1 divided by 2L into root of T by M. Fundamental frequency of vibrating string under a tension. So N is equals to 1 by 2L into root of T by M. So here law of length, law of length, N is proportional to 1 by L, M and T are constants. So N equals to constant into 1 by N. So N is equals to constant. So N1 L1 equals to N2 L2 equals to constant. Law of tension. Law of tension. So N proportional root of T. M and L both are constants. So N is equals to constant into root of T. Therefore, N divided by root T is equals to constant, or it will be N1 root T, N2 root T, which is equivalent to constant. Now, let us know about the third law, that is law of linear density. N is proportional to 1 by root m. N is equals to constant into 1 by root m. So n into root m is equals to constant. T and L are constant over here. Now, equation of a progressive wave. So by solve its formula is y is equals to a sine 2 pi n t. 2 pi n t. Now, condition for waxing. So condition for waxing for maximum amplitude over here. So now, let us begin. So here it is 2a cos 2 pi n1 minus n2 divided by 2 into t is equals to plus minus 2a. By solving this everything, we get here t is equals to 0, 1 divided by n1 minus n2, 2 divided by n1 minus n2, and so on. Periods of beat is t is equals to 1 upon n1 minus n2. Frequency n is equals to n1 minus n2 of beats. Condition for varying amplitude. So over here t is equals to 1 upon 2 times of n1 minus n2, comma 3 upon 2 times of n1 minus n2, and so on. Period of beats t is equals to 1 upon n1 minus n2. Now, one more important formula we have. So, B naught, not B naught, uh, B is equals to 10 into log base 10 I divided by I naught. I naught is minimum reference intensity. By this, we have completed this chapter as well. Thank you for watching this video. Please subscribe our channel, hit the bell icon, and do comment. Thank you for watching.